All right, and welcome to the MSN training video, and we're going to talk about the Tempstar MSN 18-speed multi-furnace. Now, the one we're going to talk about today will be the N80 and also the N92, but they also have it in the N95 and N96s. It's the MSN programmable furnaces that are on the market. We're going to talk about what makes them different and talk about how to install them and how to service them. So so it begins. We are here. The evolution of new equipment. It is here. In the last 4 to 5 years, there's been some changes. ICP is coming in, especially this past year, where everything had to be 15 SEER. You're going to see a lot more changes and a lot more efficiency coming up that we're not really used to. But this particular furnace is a communicating or a programmable furnace. Also communicates with your cell phone. It's not a communicating furnace per se, to where I can have a communicating system like the ions or those type nature. This actually will communicate with your cell phone, where you can set it up and you can service it and look at the faults and stuff, and we'll go through all that here in just a minute. At any time, maybe you want to go back and look at this, or maybe you need the manuals on this. Sometime you're at a house or under a house, and you want to know the specs on a particular unit. You can go to our website. It's tsaedsupply.com. And on that website, you'll actually be able to contact us. You'll be able to see what we have for the training. We also have a Spanish tab. We also have a podcast, and under the More tablet, you'll see where there's manuals, the videos, calendar, and a lot of other things that's on there. And that's tsaedsupply.com. So you can make sure you can put that in as your favorites and always check into that. And if you see something on that website that we don't have or need to have, just contact us up there and let us know, and we'll be glad to get it up for you. Now, on the nomenclature of these furnaces, the one that I have with me that I take around and show and do these classes on is a 92% furnace. So the numbers at the bottom will kind of go into that. But here's this first number is your N, which is your brand, which is Tempstar. We have an N model and we have an R model, but this is the N that I have with me. And then this point, these two figures here will be 92. So it's an N Tempstar 92% furnace. We move over, what kind of motor does it have? This one is the M, which is the multi 18-speed consistent torque. That's in this position. And here are heating stages. We have a single stage gas valve that's here. And then in the next position, the sixth position, we have standard NOx, the N. And then in our heating input, 7 through 9, you'll see over here the BTUs. This one is an 080, so it's 80,000 BTU. Then the next group of numbers, the 10th and 11 numbers, is 21. So we have a 21-inch wide cabinet. And the 12 and 13th is our cooling capacity. So it's a 20, so this refers to a 2,000 CFM. And so we have a 21-inch cabinet that is 2,000 CFMs, and it puts out 80,000 BTU. So make sure when you're using this particular furnace that you're using a like a 5-ton setting, or that you got to have 80,000 BTU. Now you also want to keep in mind too that 80,000 is on the low end of a 5-ton, so you could actually use this one for a 4-ton or 4.5 in that range. If you need a little bit more than 4-ton, you'll have a 5-ton drive, a 2,000 CFM capability, and you can also slow it down, and we'll show you how to do that in this video as well. So what makes this thing different? What is new to this one? This one has the 18-speed constant torque, MCT. ECM blower motor. That is new. It also has a block vent switch. That is kind of a cool thing, that if your flue gets blocked up, that will trigger that switch and shut your furnace down. And also it has an adjustable heating blower off delay, which means when my heat satisfy and the thermostat satisfy and cuts the furnace part off, the blower motor will continue to run for, say, 90 seconds, 120, 180, or whatever I set it at, to blow the rest of the heat out of the ductwork. That part's new. And also it has a NFC antenna, which is a tap away with your cell phone. This will communicate back and forth to your cell phone, kind of makes servicing and setting up a little easier. This is also this is like anything else. You can convert it to propane. It's tweening capability. You have a 4 position. This is upflow, downflow, horizontal, left or right. And then down here, I want to look at this. It's 20-year heat exchanger limited warranty. It's very important you see that they can deny a warranty on a heat exchanger if it's not installed correctly. And we need to look at this. A lot of times I see when I go out in the field is I've been out on like 90 calls out in the field, and one of the 90 calls was actually installed correctly, like the install manual says. So most people don't even look at the install manuals anymore. They just throw them off because they've been doing it 20 or 30 years or whatever. That's not the case anymore. So we have to look at those install manuals. Now, some of you that don't know, if you do know this part, you could probably fast forward to a couple more slides. We're going to talk about what is a constant torque motor. For those that don't know, where was the X13 and where did it come from? Well, General Electric is the one that came out with your first PSC motors. Back in the 80s, they were kind of what we see, like some furnaces that are 30 years old will have that PSC, and it was a high, medium, low 3-speed motor. And in its day, in its time, it was considered very efficient. Well, in 2004, Gentech acquired So the X13 was designed in 2006 to achieve a higher SEER rating. At the time was 13 SEER. And so that's why we've come up with the X13. Now, what does a constant torque motor actually mean? A constant torque motor is going to actually, when it can't breathe, or if the ductwork's too small, or the static pressure is too high, or there's resistance, it will keep torquing up to deliver the CFM that it's designed to deliver. It's the old PSC motors, the high, medium, low, were not a smart motor, so they just ran one CFM or one RPM, and then if it got dirty or it couldn't breathe or block, it would overheat the motor and slow down. So the X13 motor is a good design, but it has already gotten better. And most of if you look at these numbers, a lot of your temp star, you'll see speed taps 1, 2, 3, 4, and 5. 1 is low, 2 is medium, 3 and 4 are the same RPM. 3 is high for AC, 4 is high in heat, and usually ICP wants that 4 tab to always be with heat. And then you have a 5 pin, which is your high static pin for your AC for issues where you have ductwork issues or too small return or ductwork not sized right or deadheads or whatever. And in this case with this furnace, they're giving us 18 speeds to overcompensate or overcome the bad duct design and to generate enough airflow through that. And so with 18 speeds, you're going to be able to, I believe they're in like 60 CFM increments, so you'll be able to really dial in how much CFM you're actually needing for the particular job. So these new motors, these constant torque motors, are now 80% efficient compared to the old ones that were 60%. Now we want to look inside. Let's take the cabinet doors off. Let's look and see what this thing has in it. And you'll see basically the same as the other furnaces, the normal ESN furnaces, except this one has a block vent switch here, and then your limit switch is behind the gas valve here. Now, if you notice, ICP puts their control board on the blower motor housing. I think some of the reams used to have their control board down here. So if you ever had a basement issue and you was flooded, it would usually get the control board. And then Nordyne always had theirs underneath the flue vent. So ICP protects it, keeps it kind of well protected in this compartment here. And basically it's just like any of the other furnaces. Now, we want to talk a little bit about the upflow return air configurations and restrictions. A lot of the jobs that I go to, when I see this particular furnace and I see it in a vertical position, I always have a return duct right here on the side, and it's usually just one side because this is laying on concrete and this is probably a back wall or something, so they usually come out to one side, whether it be the right or the left. And this is common. Now on ICP, this is a 25 by 16 inch opening, and it will carry 2,000 CFMs. The problem is until you put a filter here. If you put a filter here, then you restrict that down to a 2.5-ton system. So if you have a 5-ton system and you filter a 25 by 16 filter here, you have choked down your 5-ton system to a 2.5-ton. So if you're going to do that, you have to use the other side or come out of the bottom. So you could actually put this up on a plenum and it turn up side here and then put a filter here and a filter here. That would work. But you cannot filter here. If you do, you're going to have to come out both sides or the bottom. So just keep that in mind. The other thing too is when you're laying this unit down, horizontal left or horizontal right, you cannot use those cut-in tabs on the side. It will not get enough airflow. You have to come through the bottom of that. So keep that also in mind. And I've seen a lot of them do this, and they put a RBU box and then put your tabs coming out of the side. That's fine as long as the air passes through the bottom of the furnace. Then you want to look at, this is one of the specification sheets that most people don't even bother to look at, but it's very important, especially right here. Rated certified external static pressure. Make sure whatever model number you have that your static pressure in heat is rated for that, and your cooling static pressure is this, and then here it will create your airflow here. So always keep that in mind, and we'll go through that here in just a minute. And you'll also too look at the drive, the horsepower. You have a 1/3 horsepower on the 45, and you also have a 1/2 horsepower, and you go back to a 1/3 on the 070s. So this is, if you were reading this chart up here, it would be 045, that's 45,000 BTU, 14-inch cabinet, 1,200 CFM, 17-inch cabinet, 1,400 CFM, 70,000 BTU, 14-inch cabinet, 1,200 CFM. So you can read it like that to kind of understand where you're going to be at on the CFM factors. And this is that heating blower control off delay that we talked about. Comes in 90, 120, 150, 180. It's pre-set from the factory to 120. And then your cooling has 95 and 30 seconds. It's factory set at 90, so that can be adjusted. But also keep this in mind about your static pressure on that model. On this model, as you get bigger, the heating static pressure in the heat side is a little bigger, but cooling is staying the same. So keep that in mind. You have to be 0.50 or lower in the cooling setting as well. Here's your volts. It's 115 volts. Imagine that. It is not 208 230. And anytime you put 208 230 on these furnaces, you're going to blow it up. So we have seen that happen. Some people try to do that and not even read this. But you have to have a circuit of 104 to 127 volts on it. And then you have your I was trying to see if we had our amp control. Yeah, right here, it's 35 volt amp. Then I also want to look at the gas valve. Has a minimum inlet pressure of 4.5, and a maximum inlet at 13.6. So keep that in mind when you're setting your gas pressure. Now the one that we're showing off is the N80MSN, and it is an 080-2120. And our heat needs to be set as 0.15 static, and in cooling 0.50 in static. Okay. Same thing here. Numbers are really close to the same. Just keep those in mind when you're looking at this. The other thing too, I've noticed when I go to these job sites and look at the install, no one puts a sheet metal cover under the furnace. What we do, which is fine, that's how we get through it, is they put auxiliary drain pan. Just make sure your auxiliary drain pan encloses the whole entire furnace. In case you have flames shooting out here, you're protecting the wood flooring and the rafters from fire. But keep that in mind too. So always look at this stuff when you're installing the manual to make sure. You also have a sediment trap here on your gas line. And then one thing I've seen that we'll look at some of this is some of the northern regions will put a sediment trap right here too on your flue. So as the blower motor stops and the flue starts to come back down, the liquid comes through here and it would just drop in the bottom instead of running back into your furnace. This is one of the probably the most important specs that you'll see on this one. We have a 1200 CFM furnace, putting out 45,000 BTU. Now this one comes factory set. When you look at this, this is your constant fan factory set to 1, factory set speed tap 8, and factory set speed tap 18. Now 1200 CFM. Now if you look right here at 0 resistance in cooling, I'm only going to get 1210. Now if you're pushing the limit on this and you need 1200 CFM for your cooling capacity, and let's say you do not check your static pressure. Let's say your static pressure is 0.09 to 1. Look at the CFM you're losing. Right here, that's what that puts out. If you're at a static pressure of 1.0, you're only putting out 945 CFM. So this is why this stuff's critical. And then look at in heating, if you were at that, well, if you're at cooling and it's 1.0, your heating is going to probably be somewhere in this area, maybe here, but you're looking at 400 CFMs in heat. So you can see why it's so very important to check that static pressure, because they want this one set right here around 700 CFM in heat, and then here in your cooling around the 1095 to 11. This here, and you also, these are the dead zones. So if your static pressure is 1 and you got your fan on low and you're in this area, you have got some major resistance, and your blower motor will eventually burn itself up, and also you'll probably lose a compressor as well. But you can look at the different model sizes. Here, this is a 1200, but it's an 070. Heating minimum needs to be from the factories at 15. So keep that in mind where you're looking at these readings. This one is a 090, 2000 CFM, and it's factory set at 11. And also your cooling is at 18. But you can also look here, 2000 CFM. And on the cooling, I can get 2000 right here. If I'm at 0.40 and 18 in cooling, I can still get that 2000 range there. So this is another model, has the same kind of 2000 reading here, but you can get 2200 if you're really close to resistance. You're going to be right in this. This is where they want you, around that 1985 to 2000 range, and you can see why they say that range. So these are the models here, and these are your factory settings in heat, factory and cooling. And these are your options in heating. I can go from speed 13 to 17, but in my constant fan here, I can just go between 1 and 2. So make sure you're looking at this and make sure you understand what my factory setting is. So let's say you're not hooking it to a cell phone, or you're not using it to program with your cell phone. You're going to be able to run it, and it's going to come on at these factory settings. So if we were taking a quiz right now, the model that I take with me is a N80 or N92MSN 080 2120. And so if you were trying to calculate CFMs, and the one I have is on a display model with the ductwork hooked to it, and you can take your dual manometers and actually find out what the CFM and the static pressure is. This is why, just because I set it in a house, and let's say I'm in heat mode, and I take this 2000 unit, this 2000 CFM, because let's say I need 1600 CFM, and I'm using it like a 4-ton, and in heat mode, then if I look at my static pressure, which they want you to be right in this area here, but let's say you're in 0.70 to 0.80, where it says most of where the houses are set, look how many CFMs you're going to be losing. And if you're at 1.0, you're only getting 1,000 CFMs out of this, out of a 2,000 system. You're only going to get 1,000. You're losing 50% of your capacity just because your static pressure is off. Now, if you're at 0.50 in cooling, you're going to be around that 1890 to 1900 CFM mark. So not too far off on that, but you got to keep that stuff. If you need a 2000 CFM system, you got to make sure you check these numbers out, and then you also know what your static pressure up here is. One thing too that we see, we hardly ever see this or talk about this, but the furnace is designed for minimum continuous return air temperature of 60 degrees and intermittently at 55. So make sure if you're introducing fresh air into that return, Make sure you keep in mind that the return air coming from the house is what needs to be returning in that return air, not that fresh air going in, because you could have some issues with moisture going into your heat exchanger. So keep that in mind. Also, they want you to do the freeze protection and return air temperature. The furnace should be sized to provide 100% of the design heating load requirement plus any margin that occurs because of furnace model size capacity increments. None of the furnace models can be used if the heating load is 20,000 BTUs or lower. So keep that in mind as well. So this is just a part two of that, as it kind of shows you here. Make sure you follow the guidelines. When it comes down to doing the job right the first time, don't be that company or tech that says, well, I took a 2-ton out, so I'm going to put a 2-ton back in, because you haven't checked the ductwork or you haven't checked the supply. And when you're setting this system up, you need to know what your CFM is. What I got to have? Why did I put a 2-ton in? Well, I put a 2-ton in because I need 800 CFM. And then you install this, and then you may not have 800 CFM, and you're going to get callback after callback after callback. Because what's going to happen if there's a lot of restriction, you're going to have a blower motor go out in maybe the first year, maybe 2 years, it might make it. You're going to have loud compressors, you're going to have rattling compressors, or you have a compressor that'll go out on you, and you'll need to know why that is. The days of taking out a 2-ton and putting a 2-ton back in, those days are long gone. With the new motors and furnaces, they have to be properly set up and function right to complete the install. Now, ICP looks at this as up to the installer or the contractor that is doing the install to read the install manual and make sure the furnace or air handler or equipment is set up properly in a proper install to be successful or to consider a good install. Everything has to be sized and done exactly right. And this could violate warranties in the future. So make sure the ductwork is set right and your CFMs are set right. Also, too, on this, the 115 volt. Now, this is something that's kind of, I've not seen a lot of people mention this, but as you can tell, they want you to break the power, the line voltage there at the furnace with a power switch, and make sure you have proper polarity. Basically, on 115 volt means you got to have good ground. If your polarity is off, you'll have a 10.1 display on your LED control board, and that just means you don't have a good enough ground or good enough connection on your wires. So make sure all that wire nuts are tight. Everything's tightened down on every piece of equipment you get. The wiring is exactly the same. Yellow for the contactor for the condensing unit, and then you have the same thing as you always would have. Whites for heat. Green is the fan. Sometimes they use gray for the fan, and then you have red for your hot, and then brown common, or sometimes you can use the blue. But just make sure the main thing is right here is anything under 18 gauge. Do not use it. Use 18 gauge conductors. And if your wire length is over 100 foot, make sure you're using 16 gauge. Everything, like I said, has even changed. Even the drain has even changed, and how you are to run your drain lines even has changed due to static pressure. If you look at this, this is the proper way, because here, a blower motor, your return air is a negative. So you're pushing air up into a condensing furnace. Let's say it's a 92 or higher condensing furnace up into a coil. Now, this coil is going to drain. Right now, this coil is at positive pressure. Positive pressure without air will not flow consistently. So you have to introduce air to that with either an open standpipe or an air gap around it, or if you came up here and put a T and this was left off, then it would flow. You just got to have air coming in where the two meet or before the two meet. Like here you have, if this went up, you'd have an air gap here. You could do it that way as well. These two ways are acceptable. This is not acceptable, where it's hard piped straight in, 90 down, hard pipe into a condensing furnace, and then run out. It will not drain. So here you would have to put, you can put a T, like a clean out, just don't put the cap on it. That would work. If you do have to put the cap on it, drill a hole through it at the cap, and then, or you come in with a bigger reducer bell here, like say a 2-inch down to 3/4, and then just let that drop down into that 2-inch and kind of do that. But a furnace condensate does not flow consistently when the drain is at positive pressure. This will cause issues with water issues in the blower motor. Now, this is something we've seen in the past. Why the UV light came out was to kill mold and mildew that was caused by water in the evaporator area or in the coil area getting on the insulation and causing and growing mold. All due because the water is left in the trap, and if the trap is full, where's the water going to go? Blower motor is going to suck it all in and blow it all through the unit. So you got to keep that in mind. When I get that condense and drain, the drain's got to always stay flowing and empty. Here's the other way. This is a standpipe without an end cap, and we'll show you the difference why that is. But you see, it's positive here and positive coming down here, so you have to have an open standpipe here, and or here you can do it two different ways. Where is a 1/2 inch or larger recommended T-fitting with minimum 4-inch height standpipe. So you have to have, if you do a T, they really want you to come up 4 inches off of that and leave it as a standpipe as well. Again, this is recapping. This is just about everything I see in the field is like this. You cannot hard pipe that in with a condensing furnace. It has to have some kind of air induced into the system, or you're going to have water issues, mold issues, mildew issues. A lot of issues are going to happen from that. Here is where you can see that plus symbol there. That means there's a cap. Here there's no cap. So you got to introduce air to it. Always make sure if you're in the upflow or the downflow, the drains are not hard piped together, and make sure you're using 3/4 PVC and you leave an air gap. On the condensate trap, it's kind of all self-explanatory. If you just go into the install manual and look, it'll tell you where this hose hooks in, where it travels down to and hooks in, where this one goes, and then out your condensate trap here. And it has different setups for the horizontal right. This is how you would run it. Horizontal right, make sure this is pointing up in the horizontal position, and then make sure you read the install manual on those. Let's say we got the combustion air, the moisture trap. It's like I said when I was saying earlier, this is something you see in the northern area. I think it's a good idea. We don't practice it here. We don't see it here, but it's a great idea. As you can see right here, when this flue gas is going out and the inducer motor's on and the air's coming out of the combustion, when that blower motor stops, all this turns back down to a liquid, and it's going to come down and go right here and flow right out the drain instead of running back into the furnace. So there's a couple of ways of doing it. Here, there's got a sediment here, you got a sediment trap there, and you got a sediment trap a few places, but just, it's kind of a good thing. It may not be by your code, but it's a good practice to follow. And it will cause short life to your heat exchanger if you don't get that moisture out. Now what you're looking at is the actual board that is in the N80s MSN and the N92s, 96s MSN. This is the communicating or programmable board. As you can see, I got two circles right here. This will have a LED light. If you're going manual, you'll have two buttons here to set the board. Now, like I said, this unit will come on and it'll run on the factory specs that it has, whatever model you have. It'll show up right here what your speeds are when you mash this button. You'll go through the menu option, and then you hit this one, and it's how you changes your speed. Or you can take your cell phone and connect to this. And on the cell phone, on the iPhone, your NFC antenna is right behind the clock in the top left-hand corner. On the Android, it's right dead center of the middle of the phone. So if you look at the schematics in your install manual, this is what you're going to see. A readout here, and then your antenna there. Everything else, excuse me, is identical. All right, so here's what your display settings will look like. When it's not getting a call, you're going to have an IDL or an idle. The HT is your heating mode. The CL is your cooling mode, and then you're going to have your heat pump defrost mode on some models. Some models don't have it. Continuous fan is the CFN, and then you'll have your blower, secondary unit operating blower, and you'll have some codes there. This is usually the one I'm taking out. This is what you see. There's the fault. With the last 7 faults, how to get in the fault code, how to clear it. and then you go into the HT, which is your heating blower speed. And like I said, it'll show you what number it is. You click the right button on the display to change that manually, or we'll show you how you hook it up with your phone. So these are your uh, numbers here. You got the heat off delay, like we talked about. You can change that. The cooling off delay. What direction? If you're 180 degrees, you're upflow or downflow. And if it's twinning together, is it the primary or the secondary? And then right here, you'll have the info, which is the program number and the software version. If you have to change out your control board, do not do it unless you have this information, because that has to go back exactly the same, or your furnace will not run. And then you have a component test, and then you can also reset it and go back to the factory default settings in case there's a service tech that's no longer with the company, or a different company service tech has went in and changed speeds. You can hit reset and it goes back to the default factory settings, and then you can adjust it from there. Here's what's new. It is the next generation, where you can just take your cell phone out and just connect it to this board. And we're going to show you how this works. This is the app. If you're in Google Play on your iPhone or your Android, this is the app. It's a fast OEM parts. If you type in fast parts, you'll see this. It's called the Mobile Tech. This is your app. You want to download this app, and then we're going to open the app up, and we're going to let you see how it goes from here. All right, so we're going to hit this, and this would be exactly what the screen pulls up. You open up your app, and you'll see this screen here, and you can go to installer setup or diagnosis, or if you're going to place control board. Let's say we're going to go into the installer setup on it. All right, and here's the live. This is actual live. It took me a few times before I had to look up and see why was my iPhone not connecting. And this is actually on the screen on my iPhone. Now, we had success, and you look at this is the screen you'll see. There's a heating airflow, there's cooling. Now, if you look at this screen, you can actually save these settings to a favorite, and you can go in and open up your favorite if you're going to program multiple furnaces. So what is different about this menu? What does this menu allow you to do? So what is cool about this furnace is, let's say you have, uh, when you log in, it tells you what your model number right here is. So let's say you're doing a subdivision. This is one reason why this particular technology was there. Let's say you have a contractor, and you've won the job of a whole entire subdivision. And we all know that subdivisions are made of either 3 to 4 to 5 different style kind of houses. And on your blueprints, you may have 5 different style units that require 5 different types of CFMs or airflows. This lets you go in and set all this by what you set your ductwork at and what your guesstimated static pressure should be. So you should know if you're at 0.10 or 0.80 friction rate that you're going to be able to get into that 0.50 range, especially if you upgrade your return grill just a size bigger. You shouldn't have any problem getting to the 0.50 range. So you could go in and actually size this up and say, okay, I need my heating at size or airflow at 14, cooling at 18, and my continuous fan is going to be here, and I'm going to do a 90-second on both of those. And then I can save this as a favorite and call this as, say, Model House 1 or Model House A, and then the next one can be Model House B. And you do this with no power on the furnace. So when you see this app, you can't connect the app until the power's cut off. Now you have to have power to do it manually. You don't have to have power to do it with your cell phone, but you could save each setting, and then you can program every furnace for each house, and then Sharpie on the box which house it goes to, and then when they install it, it's set up properly, ready to go. So that's what's cool about this one. And then when you go into, like I said, you'll see this screen. It'll say connect. Once you make your changes, whatever, you'll have to go through this stage again to correct. Now, when I went through that and I had 4 or 5 different times, I finally went to troubleshoot. and it said, well, here's what you have to do and where your chip is. It's real sensitive. On my iPhone with my cover, I have a auto box cover. I have to get the phone pretty close and in that right spot when I make close contact. And you get it close in that right vicinity, it will connect. If it's not connecting, you'll understand why. So keep that in mind if you're doing this and seeing the error and it's not connecting. Don't get frustrated. Hit the troubleshoot. It'll tell you what you're doing wrong and what you can do. But make sure you get that corner, like on iPhone, underneath the clock in the left-hand corner. Make sure that left-hand corner is real close to that chip, and it will instantly connect. All right, so then we go to this is where you go back to your main screen that we're looking at. And when you click heating airflow, this is what you get. And then this is the screen. This designated speed means I can set my heat from 7 to 14, but I can always get it up to 17. The factory's at 12, but it'll let me slow it down to speed 7, depending on my CFM, my static pressure, depending on all that, and my heat, the heat rise and all that. That's all that's critical. And you can do all this by this setting here. Then you'll go back and let's do cooling. And in cooling, you can go as far as you want to, 1 to 18. Let's go back real quick. I wanted to show that you can select the tonnage on the cooling too. So then you have continuous fan and you have your different speeds. You have your different speeds on the continuous fan airflow that you can select 1 through 10 on that. And that will help you dial in. If you're doing a continuous airflow, you can dial that speed in. All right, then we look at our heating blower off delay. We're going to select it, and this is the screen that pops up in it. So you have an option to go 90 seconds, 120 seconds, which is your factory default, 150 to 180. You click OK. You go back to cooling off delay, and you can go 5 seconds, 30 seconds, or the factory sets at 90 seconds, and you click OK, and you go back to this screen, and you look at, am I upflow or horizontal? Factory default is upflow horizontal, and if you're going downflow, you have to change that orientation on that. Then you go to the tweening, and you're either off and primary or you are secondary. Click OK, and it takes you back to this screen. And then we look at our summary of changes. So you'll have this screen that'll pop up next, and you hit continue, and then you have to go in and scan it to save it. So we successfully updated the board. You click done, and then you have this will pop up, and it goes back to your main screen where you can go to diagnostics, or like I said, you can go to replacing the control board, whichever one you decide to do. And then let's see, we're going to look at diagnostics. So we're going to reconnect once we save that. Now we're in the diagnostic side of it, and we're going to see the fault codes. There was 5 fault codes, and you can see I did a test on the ignition, and of course it won't fire up because I didn't have gas hooked to it. So you're going to see this code here. It'll put a 14.1 or 14.1 here. And then after you do that a few times, it's going to go to a 34.1, which is like a lockout. It's ignition proven failure. So it means it didn't sense any kind of flame or ignition. And you can look at all the troubleshooting going on, or you can troubleshoot these fault codes come up. You can clear them all out. It's also here, it's kind of neat. It's going to show you the history, and you can go in and do a run component test, and this will be leaving diagnostics, and you're going back to the main screen. But I want to go back to this screen right here. This is where I have low heat cycles. It tells you how many counts. We've had 4 counts on the blower cycles, and that particular motor that I demo has had 92 hours of life on that blower motor, and showing 3 days of service. So this will tell you the lifetime history of the furnace, the unit, and you'll be able to read your fault codes. This is something you can't see on your doing it manually. You don't see any of this. This is something as a tech you can really see the hours that's on the motor. You can see if you've had low heat, high heat. All those things are right here. How many times it's gotten a call for that. So that's what was new. And if you're going to replace the board, like I said, you got to have the program number and the software update to make sure you do that. Don't just put a motor out of the box and stick it on there and not even look to see if it's programmed. So make sure you have all that information before you swap it out. And you can do that, like I said, with no power on it. When you change the board out, or before you change the board out, you can still hook your cell phone to it, and it'll tell you what version and program number it is. And then make sure you write that down, because that's what you're going to have to set the new one up for. So let's say you're not using the cell phone and you're going strictly by the manual display. So you're going to see your idle, which is your current status. It may say HT for heat. Then you're going to go down, you'll have your fault code, and it'll tell you which fault code are. You can clear that out. If you have none, it's going to go to the next screen, which is your heating blower speed, and I can set the numbers here. Then I'm going to go down to cooling blower speed. I can set my numbers. Constant run fan, I can set my numbers, and then I have my heat off. There's my options. My cooling off is here. Direction, there's upflow or downflow. And then you can go to 20, primary and secondary, and then here's that program number will be here. And then you have a version number, you'll need that. You can do your testing if you're going to do a component test. This is what ICP recommends, is once you get it to be a final install, you need to actually run a component test on it and make sure everything goes through its cycles. And then to follow up, maintain you have 115 volts and not 208, 230. And if you don't have the right polarity, you will see a 10.1. That means tighten your wires up and make sure you got a good ground. Make sure you have 24 volts. Minimum gas pressure is 4.5 coming in, maximum 14. Make sure you have all that set up. And then this is test mode before you leave. Once you get it installed, you go through its steps. Go through this test mode. Run the test mode. It'll tell you what all you need. Purge the lines. It'll check the igniter coming on. The fan will come on. Then it'll end the test and go back into idle mode. And then don't forget to prime your condensing trap with water. Make sure you got all that done. And then, like I said, you're looking at this. Now, here's one thing I want to show you is most people have been doing it for so long, they just think it's the same as any other unit. They install it the same way, and they turn the unit on. They call for heat. It comes on. They walk away. They do not set the static pressure. They do not set the CFMs up. And a lot of times they won't even set the gas pressure. So looking at this, there's probably 3% of all contractors actually test the unit, and 3% set up the static pressure. Probably 6% only check CFMs. And you'll have a lot of people that will test for the leaks in the lines and all that. You'll have half the people do that. And then half the people will set the gas pressure when it goes off. These are things that I run into in the field that I see are not being done. So when you look at a unit and you want to know, well, this equipment don't work, it don't do this, it's because it wasn't properly set up right. ICP requires that you properly set every unit up to where that unit is successful, so that the customer has a successful experience, and then you look good to the customer. Because you got to keep in mind, you as the contractor sold the homeowner on what a good product you sell and what a good product you install. It's a good idea to make sure you read the install manual on how to install that product that you were bragging about to even get the job, and then make sure that that product has enough CFM and airflow going through it. And then make sure you have everything set up with your static pressure so that you have a long life. And then make sure you have your sediment traps, your drains working right, so that heat exchanger does not draw moisture in, and you give a short life to that furnace. So that concludes these slides. Don't forget, you have a website here that you can always go to, tsa@supply.com. If you see something there that's not there that you'd like to see that, contact us, let us know, and we'll be glad to add it for you.